All right. Hello, everyone. Welcome to another Carolina Snowflake Meetup Group event where we're going over using Streamlit to visualize data. These are our virtual meetup rules that everybody is just respectful to one another and goes on mute and uses the chat to ask questions and tries to stay on topic. Video is optional. And of course, invite a friend always and check us out on Twitter at Data Lakehouse. All of our previous meetups are on our YouTube channel. We usually get them up within a few days. The last ones are a little slower, but they're up. And we can, that's all in the discussion board, I believe, in the meetup group if you want to check out our YouTube channel. All right, so today we'll do some introductions with a quick Snowflake refresher and talk a little bit about Streamlit and some use cases for it. And then we will visualize data in Streamlit and talk a little bit about our beta program and our next events and answer any questions you guys may have.
Quick refresher on what is Snowflake. Some of you are experienced veterans with Snowflake, and others might be new to Snowflake, and everyone is always welcome. And so just in case you're new to Snowflake, just a quick reminder, we say Snowflake, really Snowflake Data Cloud. So whether it's data ingestion, data access, data distribution, data sharing, data governance, you're trying to scale up and scale down workloads and everything in between. That is really, think of Snowflake in the cloud. So really very simple description. Obviously there's very varying degrees of complexity that you're able to do within Snowflake to really meet the business cases or your use cases that you have with your data. Naturally, some of those use cases are very straightforward, data that is to be accessed by all, but then you're gonna have other data from various sources, could be transactional, could be even IoT, that's gonna have varying degrees of sensitivity that you're gonna wanna be able to control not only the transformation on that data, how that data is aggregated and disseminated throughout your organization, where some of your user groups are going to be able to see all of the individual data elements, and other groups you're going to really control that access. Think of HR data, for example. You don't want everyone to know everything about each individual as to what they make, but it's okay to maybe see across an entire subsidiary within your organization. And so lots of different ways to leverage Snowflake to your advantage. And really at the end of the day, yeah, technology is cool, but it's all about lining that up with your business use cases. Next slide, please. All right, so Drew, do you want to take it from here?
Yeah, sure. Hey, everybody. So Streamlit, I guess the topic of our meetup today is an open source framework that is going to enable users to be able to create their own machine learning and data science teams to be able to create applications without needing really to have any front-end experience. So no HTML or CSS or anything like that. It really makes it builds the ease of flexibility in creating a lot of these front-end applications to be able to present to your business users without having to, like I mentioned, having to have that front-end experience. So if you don't mind going next slide, Heather. Like I mentioned, we've got this, Streamlit's got this ability to have a lot of programmatic flexibility. So I like to think of, if you guys are familiar with R Shiny, it's a tool that's very similar to that, to where you can create these very interactive visualizations that business users are able to use. And I'll be able to show you in a little bit about the kind of extensibility that's enabled by these dashboards and the ability that Streamlit gives you to create interactive filters or interactive graphs and charts but certainly a lot of flexibility that you may not get with maybe a tool like Power BI or Tableau, in that you are able to program your own applications. And yeah, the big part, one of the big things is the ability to build machine learning apps and data science applications. And I guess we'll get into that right now. Our target data set that we're going to be looking at today is DoorDash For Work data. And the data set that I'll be using is actually a pre-built model that is part of datalakehouse.io and the pre-built models and applications that we have within there. So if you don't mind giving me screen share access, Heather, I'm going to go ahead and kind of walk through what I had done in creating my own application and how I went ahead and utilized Streamlit to be able to visualize that data. So it is still showing screen sharing is disabled for me, Heather, if you don't mind getting that.
It should be enabled. It's
okay. No,
checked. Okay, cool.
All right. So can everybody see my Visual Studio Code?
Yes, we can.
All righty. So just off the bat, what I also was able to use was Snowpark in this integration. So Snowpark is Snowflake's kind of big data tool that they've got. It's very similar to Apache Spark, if any of you guys have ever used that. Really brings home the idea of data frames and using data frames programmatically. And that's what I did. So we started out by creating a connection to our Snowflake account and creating a session right here. And obviously for the purpose of public address, I'm not going to put I've got my information masked right here, but this is kind of the way that you would want to structure your connection and then build your session object. And then from there, you can see right here, I've actually created 3 different data frames from 3 different tables in Snowflake that are a member of that session. So we've got an orders fact table, an employees dimension table, and a merchants dimension table. So all that we want to do really is we're building off of this orders fact table, which has the vast majority of our DoorDash order information, a lot of the order amounts, the order dates, the amount that the company paid, the amount that the employee paid, the amount that was above or below budget, and if it was above budget, anything like that is really going to be found in our orders fact table. And what I did was I also pulled from the employees dimension and the merchants dimension in order to get the name of the employees that are making these orders, and then the merchants who are also the places that we're ordering food from. So and just another heads up, all of this data is mock data, so we're also not sharing employee information or anything like that. So so just be aware of that. There's also some weird quirks with some of this data because it is mock data. So if something looks a little off, that's why. So went ahead, and what we did right here was with this combined DF part was we leveraged Snowpark to be able to join these 2 data sets together, the 2-dimension data sets, the employees dimension and the merchants dimension, with the orders fact table. And then so just 2 easy joins, and then we are selecting the fields that we want right here. And then we're going ahead and collecting. So Snowflake or Snowpark actually works off of what's called lazy execution. So if if I didn't put collect here or didn't put show here, it's actually not going to collect any data. It will wait until this data set's actually being executed upon, or we had a show or collect statement right here. So I went ahead and just had that collect right here just to have that data pulled. But lazy execution is basically a way to prevent large amounts of data to be pulled in locally. So kind of a cool perk there in working with Snowpark. But then moving down, I actually am going to go ahead and run this whole Streamlit application just to give you guys an idea of what we're going to be trying to build. And I'll kind of be bouncing around back and forth between that application. So that I'm able to, the code that I'm referencing can line up with what is on that application. So I'm going to bring up my command line right here, and I'm going to run just an easy Streamlit run Streamlit meetup.py command. You'll notice I'm working off of a Python notebook, but the Python file that I'm going to be executing right here, I'm not going to bring up because it's got that personal connection information for Snowflake. So, but anything that is on that file is in this Python notebook, so you're not going to be missing anything. So let me go ahead and run this, and you'll get a bunch of command line jargon output right here that will come up. But in my browser, I can actually bring this over. I've got a Chrome browser going, and we'll be able to see that this is our application. So what we've got essentially is this this date range slider at the top, which is controlling the amount of data that we want to be paying attention for a specific point in time. So I've got the last 1 year, or I've got this application set up so that we're looking at the last 1 year of data, or 1 year, I guess, of delivery dates. So anything that's been any DoorDash deliveries that have been made in the last year. So now, and you can see that if I adjust this slider at all, it's going to re-update this application such that we have a new order count, a new percentage of orders above budget, but all so that this data is basically reflecting what's in this slider time period now. So that's the first piece, and then we've got a couple different visualizations here, a couple different tiles up at the top, and then a line chart that just shows the amount that was spent on DoorDash by different spend categories. So the service fee that was part of the order, the tip that was part of the order, the actual order total, and so on and so on. And then we've got a couple other graphs here, just with the kind of occurrences in which by weather condition of the order or the delivery, and then our top 10 merchants. So, where we were ordering food from the most. So ultimately, yeah, I'll, like I mentioned, I'll keep bouncing back and forth between this so that you guys can see it. But I'll go back to the code for now and kind of go from there. But like I mentioned, we have that slider at the top that I was showing you that basically can isolate the amount of data that we want to look at in a specific time period. So we have, the way that we do that is Streamlit has this slider object right here. And the cool thing is when you move one of the values on the slider, back or forth, it outputs a value here. And since we've got kind of a double-ended slider between the start date and the end date, we get an array that is output. So like I mentioned, right here, our start date would be 2021 09/27, and our end date would be today's date. So what would be output then would be for value 01 or value, the first element of the array would be 0927, 2021, and then the second value, our end date, would be the max date, or the date of today. So we then want to leverage that in this, in kind of the way we manipulate our data sets, though. And we've got this PD combined DF, which is the one that we're really going to be pulling everything from. So with it being our source data, we want our filter to occur kind of at the root of that source data. So that's where we've got this, our filter from our slider right here. And we do more filtering, and we've got, in this next section, we do a little bit of finagling to get a month and a year, kind of like I was showing you on that line chart, where we can go month by month and show the amount of money that was spent on DoorDash that by month. So that's how we got that. And then we also run a couple metrics right here that we'll use later, but we're not going to worry too much about them right now. So the big part of this section was that we created that slider, and we've now done kind of our filtering and anything we've needed to on our source data to get the data isolated for that time period within that slider that I was showing you. And now the next part we want to do is we actually are creating some aggregated data sets based on this source data set this filter data set that we were looking at just a second ago. So and these data sets are going to help us to create the charts and those little tiles that I was referencing before, and I'll bring it up one more time just to show you. But ultimately what we're doing with those data sets is we're wanting to get it to a more aggregated format so that we're able to better create our line chart here, our bar charts here, and these metrics right here. So for our monthly orders, we're just just to mention that this is a pandas data frame as well. So we're using, we kind of go from Snowpark to pandas, and you can kind of go, back and forth using whichever one you want. Just for the ease of this one, I use pandas, but I could have reasonably used Snowpark all the way down to aggregate these data sets as well. But right here, I'm wanting to create that line chart that shows our order totals over time by month. And what I'm doing is I'm taking that month year column that I created just a second ago with just a second ago in the above code right here. And I'm grouping by that, and I want to sum the order total metrics together so that we're showing that amount spent over time. So, and then the next data set that I actually want to create is one where we're filtering on the amount of orders that went above the DoorDash for Work allotted budget. So just doing a quick filter here to say, is my order above budget? And if so, it'll be returned in the data frame. And if not, it'll be filtered out. And right here, I create another data set, another data frame where I'm just wanting to do a quick group by on the weather condition and then get the count that was on that data set as well. And then the last data set is just grabbing the grouping by our restaurant name, and then doing basically a sum on the order total to find the amount spent at that restaurant in that given amount of time. So that's we've got our data sets kind of all put together and in a format now where we want them to be able to be leveraged by Streamlit. So we now get down to to formatting and actually creating the outputs for our Streamlit app. So, up to now, this was just, raw Snowpark, raw pandas, just data manipulation. And at this point, we're trying to actually be able to put our aggregated and our cleaned data into formats that Streamlit can recognize and be able to turn into graphs and charts. So this is probably where I'll go back and forth between the application a little bit more, but so I guess hang with me. I actually might try to see if I can go split screen here. Might not be as ugly, or it might not be as pretty because it's kind of mushing things together a little bit. You see, it's a little bit the graphs don't fit necessarily well enough for us to be able to have it full screen, but this is at least going to be able to help me to show you what how the code is working with what the output is creating. So mention the slider, we've got that slider code up there, but if we go down here, we've got what's called a container, where we are building out of 5 different columns with 5 different metrics. So we've got our first metric being the order count, and we are specifying right there. And this is coming inside of a container. And we have order count. That was a metric that I'd created up here, where we are just taking the raw row count of that very first data set. So, since it's an order fact table, we've got, one record for one order inside of that table. So we're just taking a raw row count of that table. And when we do that, we're taking the sum of it, or the number of that row count, and we're just putting it right there. So that's the total amount of orders during that span of time. Now, the next metric that we've got is the percentage of orders that actually came in over budget. So over that allotted DoorDash for Work budget. And what you can see is we actually have, I guess, 55% of our orders came in over budget in that specified amount of time. So what we ended up doing was we took that, we took a metric that we created for over budget count. The data set that we had created where we filtered on is above budget. And we just took the row count of that, or over budget count, you can see right here. And we took that amount, divided it by the total number of orders, multiplied it by 100 to get it into a percentage, and then rounded off and displayed that, that metric right here. And then we kind of did the same thing with these 3 other metrics. I won't go through all of them, but you can kind of see what we're getting to now is we've with our aggregated data, we're now able to create these these metrics of interest and be able to plot them right on the page for us to be able to use. And so the next thing we actually want to go to is we want to be able to put this monthly spend by spend category onto a line chart. And what I found in actually using this was Streamlit got a little, it didn't handle the data set that I had created well. And I actually had to use one of Streamlit's integrations with Altair. You can see it up here. It's actually another data visualization package. But I had to use Altair, which actually Streamlit integrates with in order to be able to get a little bit more in the way of my own my own specifications in terms of the axes titles, some of the labels, and then the actual lines themselves. For whatever reason, if I'd just taken that aggregated data set that I created previously and put it here, this monthly orders data set, and said, hey, Streamlit, put this into a line chart, it gave me some weird amounts, and it didn't order my axes correctly. So went ahead and just created a custom integration with Altair and created a chart that way. But the nice part of Streamlit is that it kind of recognizes that there might be times where you need more hands-on specifications involved, and then you're able to kind of use your own Altair code or Plotly code, and then put that onto the page inside of Streamlit still. So it's not like Streamlit saying, it's my way or the highway. It's the ability to kind of integrate with other visualization packages. Like I mentioned, Plotly used Altair here, but a lot more flexibility, and that kind of hammers home to that point I made earlier about programmatic flexibility. There's a lot of it when you're using Streamlit. But point being, this is the route that I took to create this line chart and get it the way that I wanted to. But we also had the ability to create these box plots, or these bar charts at the bottom. And the nice part about this first one, the weather conditions bar chart, was that the data set that I curated, the PD weather data frame, actually came into good enough format for Streamlit just to be able to put on screen. So you can see right here that I just had to write st.barchart PD weather, and that was able to give me the data set the visualization that I wanted, instead of having to go through and create the Altair chart. So for ease of quick data sets and quick visualizations, Streamlit does have a strong ability to get those be able to get those created quickly and seamlessly. And then for this last bar chart, went ahead and actually switched up the axes to make it a little easier to read for the restaurant or the merchant that we ordered food from. And the only thing that I really changed here was just the axes and the chart property right here, as opposed to, so we used mark bar here, and previously for that line chart we used mark line. So back to using Altair, and again, another chart where I had a lot of flexibility to be able to rename my axes and rename recreate the width of the chart as well. So making sure that it fit to this specification instead of whatever Streamlit decided that its size was. So yeah, that's about it with regards to the with regards to some of these visualizations. But as you can see, there's again a lot of flexibility, and this was something that wasn't a huge level of wasn't a huge pain to put together. So if I just go back to the notebook, it's a matter of creating my aggregated data sets, creating some tools or some tools like the slider, and be able to integrate that with these data frames, and then ultimately just creating these charts. And it was just a matter of maybe 50 lines of Streamlit code that allowed me to create that entire application. So Streamlit, very seamless, very low maintenance to be able to get up and going to create a data science app or a machine learning application. So yeah, I guess if you were to take your next steps, then it would be to take a look at the Streamlit documentation, and we can link to that. That's very detailed, and again, a lot of these the packages that I was showing earlier are very low maintenance, low input necessary. So if you have a curated data set or a data frame, it's really just a matter of saying, hey, Streamlit, take this data frame and create a bar chart or create a line chart for me. So, but the very cool thing is that Snowflake, which bought Streamlit actually last March, just announced that Snowflake Summit that they are creating custom integration for Streamlit within the Snowsite UI. So, in the same place you would be able to see tables and schemas, databases, you'll also see what they'll be calling Streamlits. So almost your own data application within Snowsite, and that I think that's incredibly cool. But yeah, that's I guess where you would head next, and I'm sure that Snowflake will be putting out more documentation on what that integration will be looking like, very soon. So
feel free to reach out if any questions or trying to get started. We're always happy to answer questions. We have our own Slack workspace you can get to from our website. We can ask questions there or ping one of us directly on social media.
Absolutely. And I've got our GitHub link in the chat, as well as our YouTube channel, if anybody wants to refer back to the code or the video. So in case you guys aren't aware, we are AICG, developers of the Data Lakehouse platform. And you can go to our website, datalakehouse.io, to get some more information about that. And basically, we are able to sync data into your Snowflake with our ELT tool. There's no code required, and there's some machine learning involved. We've got analytics, a data catalog, all kinds of cool stuff. And this is our actual DoorDash For Work analytics dashboard, which from a business perspective can be super helpful for any company that wants to kind of look into how much their employees are taking advantage of the benefits and whether or not they need to increase budget and that kind of thing. And I believe we are the only one, to our knowledge, that offers analytics for DoorDash For Work currently. Right now, we've got an open beta program going on, which you can go to datalakehouse.io/beta if you'd like to sign up for it, and you get some cool swag and access to the Data Lakehouse platform. And this is the form you will get to on that screen to fill out if you're interested. All right, so if anybody has any additional questions, we can take those. And Peter asked if anyone is hiring. Christian or Mike, you want to take that one?
Yeah, we're definitely open for hiring data engineers, people that got a great intellectual curiosity to always ask questions about data, learn new exciting things. If that fits your personality and type of organization you look for, yeah, definitely reach out to us. We'd love to chat more.
All right, and we've got in the chat, Anna also mentioned that Code Signal is hiring. Good stuff.
Yeah, always happy to help others out as well.
All right, so our upcoming events, a little sneak peek at what we're doing is using Data Lakehouse to terraform Snowflake. We'll be having that event next month towards the end, and I will get that updated soon in the meetup group, and that should be sent out as soon as it's updated. All right, And we also went to Snowflake Summit and we did a great recap of that, which will be uploaded onto our YouTube channel also soon. So if you guys are interested in what you might have missed, check that out as well. Thank you guys all for joining, and we will see you next month when we go over using Data Lakehouse to terraform Snowflake. Thank you guys so much.